Good morning, everyone, and welcome to this webinar of PlastiCircle project. Thank you very much for joining us for this hour that we expect it will be interesting for all of you. First of all, I would like to present all the colleagues that are going to stay here today with us. Please, Ariana, can you share the presentation with the roundtable colleagues? We are going to present here the results of PlastiCircle project, but those relate to building and construction application. To share these results with all of you, we are going to have Richard McKenzie from Axion that will give us an overview of the working package 5, which is related to recycling. And also we are going to have together with us two companies that are using this recycling from the projects. Lisa Scholt from Armacell and Sven Enrich also from Armacell that will share with us the development and application of PET foams on board using mixtures of post-consumer recycling PET. Also, we'll have Amadim Matan from Derbigum that will tell us how plastic waste is used in bitumen applications for an ecological roof covering. So thank you very much to all of you. Also, Ariadna from Kim is here with us, but she's having some technical problems. So we will keep with the webinar. Saying this, I would like to share with you a short overview of this project before getting into details on these applications. You can raise your hands for Q&A for questions, or you can also write them into the chat, and we will, after the presentations, we will leave to times for questions and answers. So I'm going to explain a little bit to all of you a short overview. I only have 5 minutes, so I hope I can do it very short. But just to give you an overview of these projects. PlastiCircle is a European project that under the Horizon 2020 programs. This project is created together with a consortium of 20 pan-European partners all across Europe, and with 3 pilot cities in Romania, the Netherlands, and in Spain. This project has a 4 years duration and it will finish this May. So we are at the very last part of the project, and our aims has been to transform waste into valuable products, contributing to the European Union's efforts to move towards a circular economy. We have been working in 4 phases of project innovations: collection, transport, sorting, and recycling. As I mentioned, this project has been developed by 20 partners all across plastic value chains, with research institutes, trade associations, recyclers, waste management companies, municipalities, and which is very interesting is also that we have 3 pilot cities and 1 follower cities, where we were able to trial all the developments of this project. As I mentioned, we work in 4 phases of the plastic packaging value chains. The first developments was in the collection part of the process, where during the project we developed innovative smart containers to increase collections rates of plastic packaging waste. With these innovations, we try to increase the rates of collections and work together with the citizens, trying to develop compensation mechanisms and characterization protocols to improve the collection of plastic packaging waste. In a second part of the project, we work in the transport state of plastic packagings, creating a cost-effective waste transport system that has been connected with a cloud platform. We worked in eco-driving, route optimizations, and so on, trying to make this part of the change as efficiency as much as we can, and try to implement this in the pilot cities of the project. Moreover, in the sorting part of the project, we try to improve plastic sorting using very innovative OTIP technologies and trying to sort several plastic packaging fractions. So during the project, we were able to sort PET bottles, mono and multi-layer PET trays, high-density polyethylenes, polypropylene, both rigid and flexible, low-density polyethylene, and plastic mix. And finally, once we have improved the collection, the sorting, and the transport of the plastic packaging waste, we work in the recycling of these products, trying to develop new value-add recycled plastic products in different applications, in automotive applications, in ground rotation applications, and in several applications in building and constructions. And this is what this webinar is about. I encourage all of you to visit our website of the PlastiCircle project, where you can find much more information. And also, we would like to invite all of you to our final events that will take place in April 13th, and where you can be able to see all the developments of these 4-year projects, and explains about all the partners, and getting more in details the innovation that we have been developing in every part of the plastic packaging value chains. So this is all from my side. I hope that you enjoyed this webinar. And now I leave the room to my colleagues, Richard, that will introduce the recycling improvement of the project. Thank you very much for all of you.
Thank you, Irene. I shall share my screen. Okay, so Irene has given a very good overview of the project as a whole there. So the project is looking at the collection of recyclables, transport, sorting, and the end markets. So my name is Richard. I'm the work package leader on the work package looking at incorporating recycled content into new applications. So as an overview, secure end markets are really vital in order to improve plastics recycling, especially curbside collected packaging. Without any demand for the recycled polymers, there's no economic pull through the system to enable the collection and sorting of these materials. Traditionally, the demand back in packaging was quite low and quite weak. This is very true when we began the project many years ago. There has been quite a change over the last 5 years, looking at more effort of putting packaging back into packaging, but we still believe there is a need for even more end markets, especially for maybe the more difficult materials, which we'll go into a little bit more in this presentation. So there's definitely more desire and drive there for closed loop, but in this project we were looking at long life applications. When you are recycling back into packaging applications, oftentimes it has to be very good quality in terms of being clear, being food grade, and this is quite difficult to achieve and sometimes not even always possible. So if we can develop additional end markets, then it creates even more demand for recycled material, which then makes the collection and sorting even more economically feasible. So when we're thinking about recycling into long life products, these are products that are used primarily in the construction sector. In this sector, plastics are a really great material. Plastic it's durable, it can be relatively low cost, it can be molded easily. So there are really a lot of benefits to using plastics in construction products. They often are hidden away, so to speak, for many years and don't even need to come into contact with humans. So using recycled content is also a very good thing into these applications. Because their lifetime is so long, however, they do not tend to come to end of waste within reasonable timeframes. So Some construction products may be in place for 100 years if it's something like a PVC pipe. So if we want to incorporate recycled content, we have to look at other sources. There is some ability to do closed loop recycling for construction products, but definitely there is more potential than there is a supply of this kind of material. So in PlastiCircle, we looked at 5 different products, and we'll hear about two of these in more detail. We looked at foamed PET boards with Armacell, so that the Armacell will be presenting that shortly. As well as this, we looked at automotive parts. So CRF, which is the Research Institute for Fiat, looked at using PET and polypropylene in the manufacture of automotive parts. This was very, very successful, and they're able to incorporate a lot of recycled content. We also worked with Hahn. Hahn made ground retention products out of recycled polypropylene film, which is very novel to use PP film into an injection molding application. And this worked really well at 50% recycled content. We also had Interval, a Spanish company who make refuse sacks. So they were using the polyethylene fraction from the waste to make new refuse sacks. And again, this worked really, really well. And they were able to incorporate a lot of recycled content. We also have Derbigum, who again will be speaking shortly, who use polypropylene in bitumen modified roofing membranes. So it's quite a wide range of different products, and we tried to capture all the different polymers within the packaging waste stream. So these are the 2 we will hear more about. I just want to tell you a little bit about how we did this project. So the project started by defining the product requirements. These are the technical requirements in terms of things like the melt flow, the impact strength, the level of potential of allowable contamination. And we then evaluated different recycled materials on the market. Because of the way the project worked, we weren't able to take material from the pilots, but we used material that was already available from recyclers today. So there was a lot of work done to evaluate those different products. Then after doing the evaluation and finding some suitable feedstocks, there was the lab scale development. So at lab scale, the partners would test the different materials, the different properties to see what is and isn't feasible. Also at lab scale, it enabled them to come up with different formulations. So for many of these products, different additives were needed in order to get the end applications that are needed. Once the lab scale trials were complete, it moved into production, pilot and production scale. So lab scale, you're talking about a few kilograms of material, and then in pilot, it could be up to even a couple of tons of material. And this is really vital to understand how the material works at scale. Doing lab scale is great, and you can get a lot of information there, but you don't really know fully how the material works until it's done at a larger scale. There's also always the risk of variability within recycled materials, and again, until you try large quantities, you don't understand how that will affect the product. Whilst doing this, there's an ongoing economic and technical evaluation in order to only progress opportunities which seem to be feasible, not only technically feasible, but economically feasible. So there are, I think, a lot of additives which might be able to be used, but maybe not cost effective. And then the point of the project that we've just finished really is the final evaluation of the products from a technical and economic point of view. In the project also, we have been looking a lot at the life cycle as well, the life cycle analysis, so that has been completed as well. So from this, there's a significant level of R&D carried out to use the different polymers in the long life applications. All the manufacturers were able to successfully incorporate more recycled content, either increasing recycled content or using a different source of post-consumer recycled content that they were not previously able to use. In some of these instances, the cost overall may have increased. This is if there was the need to use additives, which may have been more expensive. But the hope is long-term that as recycling continues to develop, the recycled polymer may become more cost-effective, and overall the whole thing will be better. So in terms of ongoing opportunities, in PlastiCircle, we looked at 5 5 different products, but they were just, it's just an example of really the kind of products that could have more recycled content. So the project is a demonstration for the individual companies involved. Hopefully they've been able to source more recycled material, but for me it also shows the potential in looking at non-packaging applications and other areas where recycled content can be incorporated. So it's a very positive outcome. It is a bit more difficult for non-packaging applications in a way, especially as the tax on packaging without recycled content is going to come into effect. This will mean that people making packaging can effectively pay more for recycled content. I believe that it will be a long time until there is a surplus of polymer for recycling on the market. So I think the more and more end markets we have, the better. And I think this demonstrates that what is possible. Okay, so that's just a little overview of how we've done the project, and then we'll hear now from Armacell and Derbigum about the specifics of their products, and then please ask questions, and we'll have all questions at the end. So pop them in the chat. Thank you.
Thank you, Richard. Good morning and welcome to everyone, also from my side. I will share my screen. Okay. Yeah, my name is Lisa Scholle. My colleague Sven Hendricks and I will present you the development and applications of PET foam boards using mixed sources of post-consumer PET. First, I will introduce you to Armacell, followed by the investigations and results in the course of the PlastiCircle project, and my colleague will then introduce you to some potential applications. So let's start with some words about Armacell. Armacell is a global leader and the inventor of flexible elastomeric foams for equipment installations, as well as leading supplier of technical foams. There are two main business. Yes?
I cannot see your presentation.
Okay, sorry. Now you can see it?
Okay, thank you.
Sorry for that. Okay, so again, Armacell is a global leader and the inventor of flexible elastomeric foams for equipment installations, and as well as a leading supplier of technical foams. There are two main businesses, which are advanced insulations and engineered foams. Armacell is represented worldwide by more than 3,000 employees in 24 countries, 24 production facilities in 6 countries on 4 continents. Armacell develops solutions for a wide range of fields and markets, but we will see this in more detail later on. So let's have a look on the business of engineered PET foams. PET Foams is a business division of Armacell and is fully dedicated to PET foam technology. Since 2010, Armacell has been pioneering in the production of PET foam boards based on 100% of recycled PET. Our diverse product portfolio of innovative, eco-friendly PET foam solutions is produced in 3 locations, which are Timister-Clermont in Belgium, Brampton, Canada, and Suzhou in China. Our Armor PET foam products can be found in a range of technical applications such as wind energy, construction, rail and road transport, automotive, as well as general industries. Here are just a few examples of applications like rotor blades for wind energy, body structure or interiors for rail, road transport or automotive, modular housings, and sport equipment like surfboards. As mentioned before, our PET products are based on recycled PET. So how do we turn waste into valuable products? The post-consumer PET bottles are sorted, washed, and processed into flakes by the recycling companies. We at Armacell are using post-consumer bottle flakes to turn these into granules in our in-house granulation. The granules are then further processed into foam products like extruded PET foam boards called Arma PET Struct. After the use phase, our PET foam products are recyclable again. In the next few slides, I will present what Armacell investigated in the course of the PlastiCircle project and what results were achieved. So we first had a look at analyzing different PET materials on lab scale. We started with testing the intrinsic viscosity, the CEG, and the molecular weight distribution. And in each test, we compared the tray material provided by the project with different materials from different sources, like virgin PET, recycled PET from bottles with different quality, and tray-rich material, which is a mix of PET from bottles and PET from trays. In the graph, you can see the results for IV and CEG. And yeah, you can see that the quality of the tray material are worse than those of the other materials. This poses a challenge for the processing. What is important to mention here is that the tray provided by the project is flakes, while all other materials are granules. So the values for the granulated tray material could be even lower for IV and even higher for CEG. Besides testing the IV and CEG, the focus was on testing the so-called reactivity. This is an Armacell internal test method that indicates whether the material is suitable for our foam extrusion process. The analysis of reactivity shows the same or even a clearer picture than the analysis of CEG and IV. So the pure tray material shows a very low reactivity, and also the tray-rich material has a low reactivity. In the right graph, you can see the reactivity for a different mix of bottle and tray material, so with different proportion of tray. You can clearly see that the higher the proportion of the tray, the lower the reactivity. So when adding 20% of tray, only a fifth of the initial reactivity is given. This highlights again the need to adapt the process and the recipe for processing the tray material. Based on the findings of the lab scale analysis, the process and recipe for processing tray-rich material into foam sheets was developed. Before I go into the details, I would like to briefly explain the main influencing factors. So the mechanical properties of PET foam boards are strongly affected by the morphology of the foam, and the main impacting factors are the quality of the recycled PET, the material melt viscosity, and the extruder pressure. All these are affecting the foaming behavior in the process. To achieve optimal conditions and to obtain a homogeneous and fine-celled microstructure, the process can be adjusted by the recipe, so addition of melt modifiers, and the processing parameters like the processing temperature. So let's move on to the results from the development of recycled products on pilot scale. The raw material for the foam board production on pilot scale was selected based on the screening and the recipe development on lab scale. So we used a tray-rich material with up to 20% of tray. As we learned before, PET from trays has a lower viscosity, and therefore the use of melt modifier and the adaptation of processing temperatures are needed to keep the pressure on one side and also to achieve optimal foaming conditions. We developed a melt modifier formulation that allows to maintain melt pressure while preventing material degradation. On the right graph, you can see the impact of the temperature on the pressure. This was tested in a range of 260 to 285 And yeah, you can see here, too low temperature lead to high pressure and therefore to an unstable process, while too high temperature leads to low pressure, which makes the foaming insufficient. The best result could be achieved with a temperature around 270. Finally, we could prove that on pilot scale, with a combination of adapted processing parameters as well as newly developed melt modifier formulations, it's possible to produce foam boards from PET from trays that have a comparable quality to foam boards produced from PET from bottles. You can see here the individual test results from the demonstrator foam board that was produced in the course of the PlastiCircle project with up to 20% tray. In the following, my colleague will introduce you to possible applications with a few examples. So thank you from my side and enjoy the rest of the presentation.
Okay, so welcome everybody once again. As mentioned in the next slide, I will show you some existing and potential applications of our Armor PET foams, especially in building and construction. So there's a couple of potential applications in and around houses. So there can be foams in the roof structures, in the flooring, interiors, in the external insulation system, but also in facade claddings, some decorative elements, formworks, modular housing, and also domes. One application of our partner Pods Apart in South Africa is sustainable modular pods. So Pods Apart have created an adaptive architecture for a lot of different potential. Sorry, the screen sharing just broke. I have to share the screen again. Can you see it again? Okay. So our partner Pods Apart have developed an adaptive architecture to use composite foams based on our PET foams for different kind of so-called pods. So it could be some kind of hospitality pods in different areas, urban or corporate pods, or something like tiny houses. The use of PET and composite engineering results in a strong and lightweight modular structure that can also be easily transported into remote areas. And also, this is turning a traditionally fixed asset like a house into a movable asset. Another application of one of our customers in Canada, JD Composites, is a modular beach house. It complies with all the building codes and based on prefabricated modules, it was assembled in just 14 hours on site. It can withstand also category 5 hurricanes. It has the minimal maintenance requirements and very good energy efficiency ratings. And the total cost of this house was similar to the conventional construction. Our partner Zelthaus in Germany are currently developing a temporary shelter for refugees, also using our PET foam cores combined with PET fabric to have a monomaterial and fully recyclable solution that can provide a good insulation and shelter in summer and winter. And also this is using an innovative folding structure for easy installation on site. what was installed a couple of years ago is this dome of the Orthodox Cathedral in Paris. On the bottom, you can see the inner structure of the dome, which consists of our rPET foams, and the full structure was then coated with gold and placed on top of the building by helicopter. rPET can also be used for facade structures. So one example is the KAFD World Trade Center in Riyadh, where it was used to make very large panels of up to 14 meters length and of modular structure and different geometries. And one last example is also bridging. So in this Millennium Walkway in the UK, rPET struct was used in this pedestrian bridges and walkways. So thank you for your attention. And if you have any questions, feel free to ask them in the chat, and then we can answer at the end of the webinar. And this is our contacts. So feel free also to contact us if there are any questions afterwards. So then I will hand over to Amandine, I think.
Yes, it's my time. I will share my screen. Okay. Okay, hope you are seeing this. Good morning, everyone, and welcome to this workshop, which ends after me and Richard. So what I would like to talk to you is about first the company, who's Derbigum. What are we doing? After that, we are talking about sustainability and our part in PlastiCircle. I would like to explain you why we participate to PlastiCircle and what we benefits after this, and some pictures on the roof. So the company Derbigum is born in 1932. We are based in Belgium, but we have 350 people worldwide, and 200 are working here in Belgium. We have 2 production sites in Belgium, and we are using around 5,000 tons of polymers per year. So Derbigum have an international presence. So we are in Belgium, France, Norway, New Zealand, South Africa, and a lot of other countries. And what are we doing? So we are using bitumen, polymers, and also some fillers to make a blend. And the goal is to produce a waterproofing membrane. So we call also this roofing. Okay, here there are some pictures of PE bags containing the polymers, also a picture of the polymers. And here this is the polymers mixed inside bitumen. Okay, after we make the blend, we impregnate the non-woven reinforcement. So this is glass and also PET reinforcement with our blend and making those membranes, and they are finally rolls, and we are selling it in rolls. Okay, about the sustainability, what we are already doing before the PlastiCircle project was reusing waterproofing membranes. So we have a recycling department here that grind waterproofing membrane, and we are reusing it again. We are also using green electricity, recycled polymers, and we produce a system that allows the rainwater collect. So we are really increasing this sustainability aspect. What we wanted with the PlastiCircle project was to increase our percentage of recycled polymers. So thanks to PlastiCircle, what we achieved was to test at the lab scale 32 recycled polymers. So we have a good idea of what the European market can bring us in the polymer aspect. 3 were approved at the lab scale. At the industrial scale, there was 1 post-consumer recycled polymer approved. Why we didn't approve the 2 others was it was because of the packaging, because I said earlier that we want to work with the PE bags, and one of them was providing us big bags. It's not possible in our facilities, and the other one, it was a price question. Okay, so one polymer that you can see the picture here is approved on the industrial scale. We are currently using this for more than 1 year. And thanks to PlastiCircle, we can increase our percentage of recycled polymer from 850 to around 1,000 tons a year. On the roof, so here I share you some pictures of roof covered with Derbigum membranes. So what is important for us is to keep with or without recycled polymers the same aesthetic and the same quality. It's not possible to decrease the quality and the aesthetic of our products. Okay, that's all for me. I'm leaving the hand to Richard, I think.
Thanks, Amandine. We do have a question for you. So if everyone else, please pop some questions in the Q&A or in the chat. So Amandine,
okay, sorry.
Are you able to recycle the bitumen polymer membranes?
Yeah, like I said, so we have a recycling unit here, and we are recycling it again. So this recycled polymers that we are adding in our membranes is recycling again when the final applicator will remove his roof and replace it by a new one, maybe in 50 years. And we are taking all membranes. Yes, we are doing it. We are also recycling our production waste, because sometimes there is a failure and we are recycling it again. And we are also recycling them, you know, on the roof, you are not using the totality of the material, and we are taking it back and recycling again.
Great, and I'll ask Sven and Lisa the same question as well, actually, about your products at end of life. Are the PET foam products recyclable?
Yes, we are. So our PET foam boards are recyclable again at the end of the use phase.
Great. What's the lifetime of the different products of Sven and Lisa, the PET foam boards? I mean, do the products fail after a number of years, or is it more that the people want to change it rather than they need to change it?
Well, it certainly depends on the application. So usually the applications, the lifespan is not limited by the PET foam boards, so they are very durable, and also in applications like wind turbine rotor blades, where you have the lifespan of something like around at least 20 years. We have the fatigue thresholds of the materials, so that even under the under the constant dynamic loads of the wind rotor blade, the material can withstand it over that long period of at least 20 years.
Great, and Amadine, same for you. The bitumen roofing membranes, again, do they typical lifetime for those?
Like I said before, there are some roofs who live for 40 or 50 years. So it's a quite long life. I don't know what to add.
No, that's good. Thank you. So it's in my opinion, packaging is always going to be an area where there needs to be virgin material for food contact and quality. And I think being able to use recycled packaging then into long life products, which can last 40, 50 years, and used in construction. Again, it's, we've not really talked about maybe what the alternatives are, but things like the foam PET boards, I imagine it's quite revolutionary in terms of weight and strength, and has really been able to help things like wind power. So in some instances, there just aren't non-plastic alternatives. In other instances, maybe the non-plastic alternatives might be more damaging to the environment. So it's great to see the use of plastics there. Any other questions from anyone in the chat or Q&A? No? Okay, in that case, I'll hand back to Irene to close out the, oh, sorry, one has just come in. We've got we've got a moment, so I'll see if we can answer that, if I can find it. I think it was someone saying that they are also recycling materials with vinyl. Okay, I shall hand over to Irene now. So thank you very much, everybody. Again, you have people's contacts, so I guess if there are any other questions you want to ask following up, please feel free to do so. Thank you. You're muted, Irene.
Yeah, thank you. Sorry for that. Thank you very much for all the attendees to this webinar. Since you all have the content of the panelists, please feel free to contact any of us for any further questions or comments that you have. And I encourage also to save the dates for the final forum of this PlastiCircle project, where we present all the developments and innovations that we have been developing in 4 years across the plastic packaging value chains to increase the recyclings. And once more, it has been proved that collaboration is key to foster circularity of plastics. So, I see that one person has raised its hand. So, please, if you have any questions, please just go on. Put your microphone on and just make the question. You can do it online. No? Okay. Then it was you can write an email or contact the panelists for further questions. So thank you very much to all of you. We finished very much on times, and save the date, and we hope to see you all on April 13. So thank you very much, and bye-bye.